Assalamualaikum and welcome back to my video presentation on problem-based learning. Problems are the heart of PBL. They function as a content and knowledge organizer, a learning environment contextualizer, thinking or reasoning stimulator, and a learning motivator. In this video presentation, I will be sharing a specific problem design model called 3C3R. This model offers a more practical way or step-by-step process of designing a PBL problem to cover both the core and process components of PBL. The 3C3R PBL model design is a systematic method developed by Professor Wei Hung to guide instructional designers and educators to design effective PBL problems for all levels of learners, and thereby strengthening the characteristic of PBL and alleviating implementation issues revealed in previous research on PBL. Wei Hung's 3C3R model was the result of problems faced by most PBL practitioners in the early 1990s. Among the main problems they had been facing is the failure to achieve the minimum requirement of the learning outcomes in terms of content, learning process, and skills. One of the findings cited by Wei Hung is from the study conducted by Dolmans, Geisliers, Smith, and Van der Meer, 1993, which found that only 64% of the content generated by students in learning issues during the learning process using the PBL approach. 3C3R problem design model was introduced to help PBL practitioners improve the attainment of the learning outcomes, especially in terms of the content, through a structured and comprehensive problem-solving approach. This problem design model consists of two classes of components: core components and processing components. The core components are used to support learning content and concept, whereas the processing components are concerned with the learner's cognitive processes and problem-solving skills. The core components of the 3C3R model, which is content, context, and connection, are primarily concerned with the issues of the appropriateness and sufficiency of content knowledge, knowledge contextualization, and knowledge integration. The dilemmas educators and students were most concerned with are the issues of depth versus breadth and factual knowledge versus higher order thinking skills. The content component, when designing PBL problems, several aspects of the content component must be taken into consideration. One is aligning with curricular standards to set goals and objectives in accordance with the course or curricular standards. Two, scope of the problems, conduct task analysis such as using learning hierarchy analysis, and three, to design PBL problems with appropriate depth, complexity, and ill-structuredness. In considering the context component of PBL problems, there are three important design elements that need to be taken into consideration. One is contextual validity, two is a degree of contextualizations, and three, students' motivation. One, the contextual validity in PBL problems should be evaluated by examining the clinical, practical relevance to the learner's future professional settings. Two, the appropriate degree of contextualization in designing PBL problems will depend upon the learner's projected future settings. And three, students' motivation, proximity to the learner's needs for future professional development or immediate everyday life is a strategic design issues for the context component in the 3C3R model. The third core component is connection. To solve ill-structured problems effectively, the problem solvers not only have to possess a rich repertoire of necessary knowledge, they also must interlink these diverse sources and knowledge into an effective knowledge-based network and be able to cross-reference related concepts. The connection components functions to interweave the concepts and information within the conceptual framework and content into context. Several approaches can be used to incorporate connection components in PBL problem design. One is the prerequisite approach, two is overlapping approach, and three, multifacets approach. The prerequisite approach can establish the PBL problem's connection component in a conceptually logical order from simple or basic to complex or advanced. Two, through the overlapping approach, the concepts group into a set of problems. Each concept does not appear exclusively in one problem. The concepts appear in several problems so that the learners can study each concept in relation to other concepts. By understanding multiple sets of concepts involved in multiple problems, the learners link these sub-networks into a larger and more complete network. And three, through multifaceted approach. The characteristics of or nature of the variables or concepts could change from one context to another or over time. The same concept are incorporated into multiple problems with different contexts. It will help learners understand the multifaceted effects of variables. The overlapping approach helps students link related concepts within a particular domain or context, while the multifaceted approach takes it to the next level and enables students to integrate the conceptual networks more fully by interlinking concepts among different domains and contexts. The processing components. To ensure that the desired learning outcomes do occur in the course of PBL process, another class of components in the 3C3R model, processing components, is designed to facilitate mindful and meaningful engagement in PBL. The processing components, which include researching, reasoning, and reflecting, are the dynamic elements in relation to the static core components in the 3C3R model. The functions of these dynamic components are twofold. First, to serve as an activator, that is to guide the learners to take advantage of the design of the core components. Second is a function as a calibration system, which is to one to guide students learning towards the intended learning goals, two to adjust the level of cognitive processing required during the course of PBL in accordance with the cognitive readiness of the learners, and three to alleviate the issue of students' initial unfamiliarity and discomfort with PBL. The first stage of problem-solving process is understanding the problem, also termed problem space construction. The main task in this stage is researching necessary information within the domain as preparation for the next stage of the problem-solving process. Learners may deviate from the intended content area if they are not directed properly because ill-structured problems are naturally open to interpretation. Learners should be aware and properly facilitated towards the goals and context specification. The goal specification of researching is the endpoint of the problem space significantly directs their learning. The goal state of PBL problems should be explicitly stipulated in order to direct the learners toward the content information specified by the content component. Without a clear specific goal state for the problem, learners are unlikely to engage in systematic researching processes. In most professions, domain knowledge is highly context specific. Some concepts or principles may be the common foundation for several fields or professions, yet their applications could be drastically different from one profession to another. The context determines the learner's initial frame of reference and influence their researching and processing of the information. Thus, it is important to situate the learning within the conventional researching processes practiced by the professional in the particular field. The reasoning is the processing component that promotes the application of knowledge acquired from researching related information and the development of learners' problem-solving skills. By being required to analyze information and generate the test hypothesis and solution to the problems, the learners put their knowledge into practice instead of only memorizing it. During this process, problem solvers engage in the cognitive activities that enable them to solve the problem. This includes one, analyzing the nature of all variables and the interrelationships among them, two, linking newly acquired knowledge with existing knowledge and restructuring their domain knowledge base, three, reasoning causally to understand the intercausal relationship among the variables and the underlying mechanism, and four, reasoning logically to generate and test hypotheses as well as identify possible solution or eliminate implausible solutions. By engaging in these cognitive activities, the problem solvers process the somewhat raw knowledge into meaningful, applicable, and conceptually integrated knowledge. In essence, the reasoning process enables problem solvers to deepen and expand their conceptual understanding. Researching and reasoning processes occur simultaneously and reiteratively, and they complement each other in enabling an effective and efficient problem-solving process. And thus, these two processing components should be considered simultaneously. Reflecting. In the model of PBL proposed by Barrows and Myers, knowledge abstraction, summary, and self-evaluation are three main meta-cognitive activities designed to help learners achieve optimal learning outcomes. By reflecting on the knowledge they have constructed throughout the problem-solving process, learners have an opportunity to organize and integrate their knowledge into a more systematic conceptual framework. Reflecting involves the cognitive activities of abstracting, summarizing, and organizing knowledge to enhance learners' conceptual integration and retention of the topic under study. Through self-evaluation of their problem-solving strategies and exploring and examining alternative hypotheses and solutions that they might have missed, learners can improve their problem-solving and learning skills through metacognitive processes. These reflection activities can extend students' learning by helping them discover information, concepts, and areas that they can explore further, as well as enhance their ability to transfer knowledge to different contexts. The reflecting components acts as a built-in metacognitive guide in PBL problems. This component optimizes the PBL processes by ensuring the maximum effects of other components in the PBL problems. When designing the reflecting component in the PBL problems, two types of reflective processes, formative and summative, could be considered. A formative reflective process should occur throughout the PBL course, along with the processes of researching and reasoning. The learners should evaluate and reflect on their problem solving and learning processes and adjust their strategies accordingly during the course of learning. Another type of reflecting component is a summative reflective process, which concerns over the result or the products of learning. It also involves the overall reflection on the process of learning. The reflecting component should also encourage learners to reflect upon their learning achievement and cultivate within them the habits of experts. In outcome-based education curriculum model, the summative reflection is a base for continuous quality improvement process, or CQI. The 3C3R model is a comprehensive guiding principle for PBL practitioners to design an authentic PBL problem based on the real-world scenario and meet the intended learning outcomes of a study course or program. In the next video presentation, I will be sharing a step-by-step problem design process using 3C3R model. This could be a good start for PBL practitioners and educators to find the best way of designing problems to meet the intended learning outcomes of any specific study course or program. Thank you very much for your time and kind attention to my presentation. Viewers who are new here, please subscribe to my channel so you will get more notification on my upcoming videos. And don't forget to like and share this video. And if you have something to share, please leave the comment below and have a great day. Assalamualaikum warahmatullahi wabarakatuh.